Hi! It's time. Okay, it is time for 4.4 number 2. I wish I could have done this earlier, but I just didn't have the time, but I got the time now. Lucky you, lucky me. All right, so 4.4 number 2. Same old chicken adventure, but now the chicken is in motion. The chicken is going 5 meters per second, which is pretty good for a chicken on skis, on level ground. Now, chickens don't just go 5 meters per second on level ground. Normally, somebody usually needs to give them some help. You're giving them some help. You're providing 30 newtons of force to make that chicken go. Now, what we're trying to find out is the acceleration. What is the acceleration? Using F equals ma. So, the mass of the chicken remains 3.2 kilograms. We are trying to find A. But is this the only force acting on your chicken? Well, once again, it wouldn't be a chicken for you now, would it? It would be whatever your pet is. In my case, it's a chicken because that's all I got. But there's another force playing a part here. The other force is the force of friction. You apply a forward force, the force of friction resists. After all, if you weren't pushing that chicken wouldn't just obey Newton's first law and go on forever. That chicken would come to a stop because of friction. So, we need to think about that. We need to think about the fact that it's the sum of the forces. So, it's not just the 30 newtons you're applying, you're also having to take into account the force of friction working against you. Now, if you'll recall, the force of friction is actually the coefficient of friction times the normal force. Now on level ground, 3.2 kilograms, on level ground, the normal force is going to be equal to the weight. So in fact, it's 30 newtons minus the coefficient of friction times your mass times 9.8. Now, the mass we already have, it's the same chicken, same mass here, same mass here. That'll be 3.2 kg. So I'm ready to start filling in. 30 newtons minus, now wait a second here. I know a lot of you are thinking, we already figured out the force of friction, didn't we? Didn't we? We used the coefficient of friction that was 0.14, right? But if you remember, I gave you 2 coefficients of friction. I gave you a coefficient of static friction, which was equal to 0.14, but I also gave you a coefficient of kinetic friction, which is equal to 0.10. You used that one for when the chicken was sitting still. But if your pet is not staying still, if it's moving, you should use this one. But is it moving? Well, it is. Remember in the assignment I said 5 meters per second? Now, a lot of people, they look around and say, well, where do I put 5 in? You don't. The 5 is just there simply to say that this is a chicken in motion. This is a bird in motion or your pet in motion. So that's telling you you're not going to use a static friction. You're going to use kinetic friction. And it also means you can't borrow your static friction number from the first one because you're not staying still anymore. This is a sliding pet. So we're going to have to put that one in. 0.1 times the mass, 3.2, times gravity equals 3.2 kg times acceleration. All right, so 9.8 times 3.2, so let's see. 9.8 times 3.2 gives us 31.36. That's the weight of my chicken. You probably already have the weight of your pet because you already probably have that in your biometrics page, don't you? But just multiply it by 0.1, and you get 3.136 equals 3.2 kGA. So 30 minus 3.1, in my case, I get 26 point, what do I get? 26 point, oh boy, I don't remember. 26 point, what is it? 864, is that right? Close enough. Equals 30 kg. Now, by the way, the newtons I'm putting in is bigger than the newtons I'm taking out. That might not be the case in your case. There is a distinct possibility that the force of friction will be greater than 30. That will give you a negative number. Does that mean that your calculations are wrong? No. It just means that your animal is so heavy that it's producing so much friction that 30 newtons just isn't enough to keep it moving at a constant speed. In that case, your acceleration is negative because you're slowing down. You just can't keep up at 5 meters per second. You're going to slow and slow and slow until eventually you come to a stop, and then that's the end of that. So if you've got a very large dog or a lion or a horse, you can expect that this is going to be bigger and it's going to probably bring you to a stop. However, if you've got something smaller, you're probably going to keep accelerating. Now, by the way, okay, so divide both sides by 3.2, divide by 3.2, and you get, oh dear, 3.2 times 8. Hold on, well, unfortunately my calculator is being used as a filming device. Oh wait, do we have another calculator? I do! Hold on. I didn't actually do it this way the first time around. And my calculator doesn't work. Shall we just say, I have down 8.3. That may be wrong. I don't know if that's right or wrong. You're not going to get the same number anyway, but it's certainly in the right neighborhood. I have 8.3 down. So I'm saying 8.3 meters per second squared is equal to acceleration. I'm probably going to hear about this if I got it wrong. It might be. Certainly around about 8. Not so sure about that part because I did the calculations before I started filming and then I realized I made a small error and I corrected it as much as I could in my mind, but I'm not sure whether or not I actually really made an error. But anyway, long story short, this is roughly the right ballpark. If your animal is less than 3.2, if you got a hedgehog or something like that, your number will be considerably larger. If chances are you probably got something that's bigger than a chicken, your number will be smaller. Have your object, have your chicken, requires more force to accelerate. Not only would you not have as much mutual force because you'll have more friction, but the sum of the force will be smaller, but the mass will be larger, so it'll make it a much smaller number for most of you. And it may be negative if the animal is so big that you cannot keep it moving. But anyway, there you are. Sorry to bother you.